Okay, today we'll be talking about the mole concept, and what you need to understand for the mole is these few things lah. Number one, what is the definition of relative atomic mass and molecular mass? How to calculate MR? How to calculate number of moles? Percentage purity? Empirical formula? Molecular volume, which is and at the same time concentration. So why do we need to actually redefine what is a relative atomic mass? So relative, the meaning of relative means approximate. Okay, approximate atomic means atoms and then the mass. So generally it's actually very impractical to measure the actual mass of an atom. Whereas the mass of an atom, usually what we do is we want to base it to an approximation or a baseline standard, and that will be your carbon 12. Carbon 12 is used, right? Carbon atom with the mass of 12 is used because it is usually easily found around the world. So what exactly is relative atomic mass? It is actually the relative atomic mass of an atom is the average mass of one atom of that particular element when compared to 1/12 of the mass of one carbon 12 atom. In a maths formula kind of way, it's basically the number of the average mass of all the atom within that of the element divided by 1/12 mass of an atom of carbon 12. So it's like 12 times 1 over 12 times 12 is 1. So generally, the relative atomic mass of carbon 12 is taken to be 12. This can be represented in the AR as an AR and that there is no units on it. On a periodic table, this is the old periodic table. How it's usually found, right, is generally at the bottom number. So now the new one is you have the symbol in the middle, the number of proton at the top, and which is the atomic number, followed by the mass number, which is 24 at the bottom. One easy way to remember is that relative atomic mass is the larger number out of the two numbers. However, in exam, if you are still required to write a symbol or some form of representation, you should still write it in the form of 2412. Okay. For mass, it can be written as mg-24. So one way to realize this is when we look at chlorine, right? Chlorine actually has a decimal point here. Okay, and the reason why they are not whole numbers, right, is because of the concept of average in this case. Now, what does it mean by average? So let's say I have a basket of fruit with a lot of apples. Okay, and out of these apples, right, there is actually of maybe of different of mass 5, you have maybe 6 and a 5. So what we meant by, let's say I'm asked what is the relative atomic mass of the apple, it will be the total, all the individual mass of the apple divided by 3. And in this case, 10, 16, 15, 15, 16 divided by 3, we have 5 point something. So this itself is what we meant by relative atomic mass. So just like the element that we have, they can have many different ones. If let's say there's orange, right, then of course we exclude the orange if you are looking at atomic mass. But when we have the oranges or other fruits, right, then will no longer be considered as atomic mass, it will be molecular mass. So generally when we see, right, for chlorine, right, they tend to exist in two different isotope forms. So if you recall in chapter 5, atomic structure, isotope is basically atoms of the same element with the same number of protons but different number of neutrons. And this will lead to it having different mass number. Another thing that over here we look at is this one, 75 and 25%, meaning the abundance. So let's say we consider again a basket of chlorine, right? 35% of the chlorine fruit will have mass 35, and 25% of the chlorine fruits in this case, in a fruit basket analogy, it's 37. So what we do is we want to actually take the average to calculate the relative atomic mass of chlorine. So in this case, it will be 75% multiplied by 35, the mass, and 25% multiplied by 37 of the mass, and you sum it up together. So it takes into account the relative abundance, which is the number of percentage or the proportion of all the isotopes of the element. And this is the reason why the relative atomic mass of certain elements are not whole numbers. Moving on, we look at the relative molecular mass of a molecule, of a molecular substance. And in this case, we just have to change the word atoms to molecules, where it becomes either an element or compound. Again, the other key things is still the same. So it's usually, rather than represented by AR, for relative molecular mass, it's represented by MR. And this is the sum of all the AR of the atom in the molecule. Again, there is no units for this particular item. So how do we go about calculating? So this one generally in exam, it will be worth 1 mark. You will be required to actually know how to calculate. So in this case, you look at the periodic table, identify what's the mass of a carbon atom, which is 12, and one oxygen atom, which is actually 16. Then you take the sum of it, which is 12 plus 16 plus 16. Why there's 216? Because there is 2 oxygen atoms. And that will be the answer, 44. Okay, again, please remember this definition, as this is a common exam question. In exam, they will either ask for AR or MR definition, and that's about 2 marks. For ammonia, it will be for the mass of 14 with H is 1. So that since there's 3 hydrogen atoms, it will be 14 plus 3 times 1. You will get 17. A relative formula mass tends to be it's actually a more accurate way to refer to the MR of ionic compounds. And it is not a representation of by the symbol MR and has no units. It is calculated in exactly the same way as your relative molecular mass. So what is meant by this is that you have even more kinds of formula where you, like for example, for magnesium sulfate, you have the Mg2 plus combined with the anion SO4 2 minus. So when both of them combine together, what we will see is that the calculation will still be the same, where you have 24 from magnesium. Sulfur, we have 1, so it's basically 32 plus 4 oxygen, which is 16. In all, this will give you 120. And this would be the relative molecular formula mass of magnesium sulfate. In the event you see a dot here, this dot doesn't mean multiplication or what's not, but mainly it's how a separation of copper 2 sulfate with the water molecules. However, in the actual solution, you will see that there's some form of interaction between the water molecules only with this copper 2 sulfate. That's why there's a dot. All you have to do is just break it down, where MR of copper 2 sulfate is just 64. That plus 32 plus 4 of oxygen, which is 16. Okay, so this will be the MR of copper 2 sulfate. On the other hand, for water, it will be 1 plus 1 plus 16, giving you 18. But because there's a big 5 in front of the water, you would have to take the multiplication of 5 throughout the whole of 18. Then you sum it up together, you'll get the answer 250. Next, we move on to mole and molar mass. So for some items, generally it's easier to use other units to actually count them. For example, the number of shoes. We don't go and take a length and then go and measure the length of the shoe and then calculate it. Rather, we actually count physically the number of times it has So for example, there will be 2 shoes, so it's 1 plus 1. Color pencil, if let's say there's altogether a thousand of color pencils, there will be a total of 12, and so on and so forth. However, for atoms, right, because they are too small to count physically, therefore we generally, other than using mass, we can use a rough estimate called mole. Okay, so the mole is basically a unit of measurement, just like cm for length. So the mole is actually a unit of measurement for the very small particles, such as your atom, molecule, ions, and even electrons. This is generally represented by the symbol mol. Okay, mole. And just to take note that for a mole of a substance it will actually contain the same number of particles as the number of particles in 12 grams of carbon 12. So what is this special number? So there are many different researchers that actually went to identify or even to really physically go and, in a way, like count that for every 1 mole of any substance, it will actually have 6 times 10 to the power 23 particles. Meaning for 1 mole, let's say I have 1 scoop of milk powder, right? I'm able to actually have maybe 6 times 10 to the power 23, 4 small fine particle powder within that scoop. So that's generally how it is. Okay, and this is what we call the Avogadro's number, where you have to remember this number. It's good to remember. But actually, a more accurate one is this. So next is how big is a mole? So let's say we have 1 mole of people. 1 mole of people will actually cover the whole surface of Earth. Or 1 mole of people standing on top of each other will reach beyond the moon. So that's how relative mole is if we scale it down to people or what. So what happens is whenever we talk about 1 mole, right, regardless of whatever elements or condition, it will always contain the same number of particles um, as there's actually a formula that you can relate to where the number of moles equals to number of particles over 6 times 10 to the power 23. This is constant, it will not change. This can be derived from another formula, and the number of particles can only be calculated from here. Now, do take note that number of particles, the question was specifically ask you what is the number of particles, then you use this formula. Otherwise, most of the time it's mass, if not, it's number of moles. So, for example, this question, how many moles of iron contains 2.7 times 10 to the power 24 iron atom? So this would represent the number of particles. You would have to divide it by 6 times 10 to the power 23 to get the number of moles. Moles generally are very, very small numbers. It can go lesser than 1, okay, or definitely more than 0, but lesser than 1, or highest would also go to a 5 or 10, around that range. Any value more than that, you have to be quite careful because either there's some calculation error for number of moles, if not is you are using very, very heavy. How heavy is heavy? You are looking at mass of maybe in tons, okay, for your calculations. So generally, they are more or less the same. So regardless of is it atoms or molecules, more importantly is we refer it based on the number of moles. Next is molar mass. So molar mass of an element is the mass of 1 mole of the atom of the element. So let's say for neon, which AR is 20, the molar mass would be 20 grams per mole. And do take note, molar mass is actually has units of grams per mole. So in exam, just be very careful with how you use the term. If they ask for MR, AR, no units required, but they ask for molar mass, you will need to write the unit. Okay, so let's look at how then is the formula involving number of moles and moles related then. Number of moles and molar mass related then. So the number of moles of a substance will be equals to the mass of a substance over the molar mass of the substance. So one is in grams, the other is grams per mole. So one thing to take note is whenever we look at number of moles, most of the time is from a calculation point of view. If not, you will be given in the question. Mass of the substance, most of the time is again either you calculate or from question. To start initial discussion, usually they will give it in the question. Then you have to find the mass of another substance. You cannot find it from the periodic table or anywhere else. Molar mass can be calculated only from the periodic table. And that is basically your AR or MR. So be very careful with how the different calculations are. Second is the units. The units play a role in terms of having everything correct. So you don't have to actually do, you may have to do conversion for either mass of substance or number of moles of the substance. So in a nutshell, this is the main relationship between number of moles, mass, and molar mass, where the number of moles is equals to mass over molar mass. And this triangle can be a very good representation of this identity. Okay, I will pause here for a while to recap some of the, for you to have some time to actually look through it, and then we will continue again in a subsequent session. Thank you.